Good morning to all. Good morning to all. Today we can discuss about the non-linear equalization. So mainly the equalization is a technique which is used to eliminate the intersymbol interference. The major classification of equalization techniques are linear and non-linear equalization. So mainly in linear equalizer, if the output is not used in the feedback path to adapt the equalizer, then we are calling that as linear equalizer. And if the output is fed back to change the subsequent outputs of the equalizer, then this type of equalizers are called non-linear equalizers. Today we can see detail about the non-linear equalizer. So the non-linear equalizer has several types. One is the decision feedback equalization. The second one is maximum likelihood detection. And the third one should be the maximum likelihood sequence estimation. So in the decision feedback equalization is particularly useful for the channels with severe amplitude distortion and has been widely used in wireless communication. So what the basic principle used is the value of the information symbols already detected, then the ISI contributed by the symbols can be cancelled exactly by subtracting the paused symbol values with appropriate weighting from the equalizer output. This can be realized in direct transversal form as well as the lattice form. So we can implement both in transversal as well as the lattice filter. The decision feedback equalizer consists of a feed forward filter and feedback filter. The feedback filter is driven by decisions on the output of the detector, and its coefficients can be adjusted to cancel ISI on the current symbol from past detected symbol. Diagram shows the feed forward filter, which is having the N1 plus N2 plus 1 tabs and N3 tabs in the feedback filter. So it should be equivalent to the summation of the filter coefficients, the product of the filter coefficients and its output, and plus the feedback element. So the symbol represents the decision output. The decision output will be based on the previous decision made on the detected signal. So the decision feedback equalizer has the predictive nature. So another form of the decision feedback equalizer proposed by Belfer and Park is predictive decision feedback. It consists of a feed forward filter as in this, but feedback filter is driven by an input sequence formed by the difference of output detector and output of feedback forward filter. So that we can call it as a noise predictor because it predicts the noise in signal at the feed forward filter output and subtract the detector output from it. At last, the mean square error of the decision feedback system is evaluated and it should be fed to the input. So what are the advantages of this one should be? It performs its role as the conventional decision feedback filter as the limit in the number of taps is approaching infinity. The feedback filter in the predictive decision feedback equalizer can also be realized as a lattice structure. For the fast convergence, the RLS lattice square algorithm can be used. Next is maximum likelihood sequence estimator. In this type of equalizer, we have a classical maximum likelihood receiver structure. In this, you have a matched filter, a maximum likelihood sequence estimator, followed by a channel estimator. So it is usually using this Viterbi algorithm. This Viterbi algorithm, it is by considering that will be nothing but your estimator algorithm, which tests for all possible data sequences and chooses the data sequence with the maximum probability as the output. It has a large computational requirement, especially when the delay spread of the channel is large. Using this maximum likelihood equalizer, which is first proposed by Oni, a scientist called, he set up a maximum likelihood structure which is with the Viterbi algorithm. And the second one, which is designed, is using another one type of algorithm. Based on the decision, it is going to choose the optimal value by minimizing the probability of error. So the matched filter operates on the continuous time signal. So whereas the maximum likelihood sequence estimator and channel estimator rely only on discretized samples, that has to be so for that reason we are using a sampling after the matched filter. So this is how we are going to classify the nonlinear equalization. We have always the feedback from your error. The error signal should be the difference between the received signal and the estimated signal. Thank you.